Sahi ma'am, we shall just start.
Yes, sir.
Yeah. So, on behalf of the Department of Civil Engineering, we welcome you all for the second session of the first day. We are having our CSIR funded workshop on emerging trends in sustainable and resilient infrastructure, which is going online as well as offline. So, it's in a hybrid mode from today. For 6 days, we will be having different sessions. So, in the morning session, we had Dr. Smita Govindath, Senior Principal Scientist, CSIR Chennai, CSIR SCRC Chennai. Ma'am spoke about the emerging trends in sustainable and resilient infrastructure, the title, as well as ma'am has introduced all the stakeholders about the textile reinforced concrete, TRC, which is a noil material which is used for construction. So now this session we have Ms. Mary Benisha. Ma'am is an associate professor from Pondicherry College of Engineering from Nagarkoil, Tamil Nadu. And on behalf of the Department of Civil Engineering and the organizing committee of CSIR funded workshop of emerging trends in sustainable and resilient infrastructure, we uh, we all a hearty welcome to you, ma'am, on this session. Over to you, Sahi, ma'am, for a brief introduction about the speaker as well as the session.
Yeah, thank you, sir. I'm happy to be here. Yeah, so it's my pleasure to be here to present my views. So I welcome you all for this online funded workshop. On behalf of Civil Engineering Department of H Institute, I welcome you all. And the topic I'm going to share here is the modern, sustainable, and resilient materials. So I hope it's time to share my PPT.
Sahi, miss, are you there?
Yes, sir.
So, ma'am can share the slide or you want to speak, add on something?
Um, no, I hope I can share.
Yeah.
Can you able to view my slides?
Yes,
Yes,
ma'am.
ma'am.
Yeah.
Yeah, thank you. So this is a pleasure for me to be here with you all. So I'm here for in this field of teaching for nearly 15 years, and now I'm working as associate professor in Department of Civil Engineering, Pondicherry College of Engineering. Right. So as an overview for this presentation, I can give some topics, what I'm going to discuss. That is, what is sustainability? So the definition for that and all those terms. Then we cannot forget or we cannot have a sustainable field without the nature. Also that I have made green structures in that and what is a green infrastructure. Next will be what is a resilient infrastructure and then what is sustainable construction. So certainly when we learn the sustainable construction, we have to know about the building material, sustainable building materials. And if it have to be a resilient material, then we have to talk certainly about the smart materials in architecture. Then at last, the life cycle assessment, the rating systems, and coalition with the other terms, everything I have planned to discuss. So next, we can start with what is sustainability. So, as we are all familiar with the word sustainability, simply we can say that we are providing a base for the future generation what we are experiencing, what we are enjoying in this earth. They have to be also experience and they have to be also enjoy the clean air, clean water, and the other natural resources. So if we are over exploiting the natural resources, which is all granted to us, the future generation they cannot go with that. Is it? So this is a aim for the whole usage of natural materials, very concerned, right? So as a simple meaning, but when we talk technically, what is a sustainability? I can say developing our society, giving opportunity to improve our society, the economical activities and social conditions without compromising the quality of the materials or the natural elements, right? The next is the three term or the main thing we have to focus when we talk about sustainability. So sustainability will not be fulfilled when we only focus on the environment, right? So environment is a part. So three parts we have to, or three sections we have to concentrate when we are talking about sustainability. So the first thing is the community. So community is the social activities and the people what we are making sustainable. So the relationship with the people. So this have to be very smooth, and this should not be, there should not be any conflict, and making a sustainable with the community, and certainly the economic, right? The economical condition have to be a healthier one, and certainly the environmental condition. So we are depleting the fuels and water resources, the air, whatever is given as a blessing for us. Now we are having some what difficulty in managing and usaging of those resources. So we are going to learn how to use all these three things equally, right? Without spoiling them. And we are going to present this very what? Very much in a good condition to our future generation. The next is, as I told, green infrastructure, right? So, what is a green infrastructure, or how to make the present infrastructure green? That is, we can renovate the old building to be a green building also. It is possible. Not only going with a in an initial stage, designing and building a new one. It is not necessary. So whenever we use the energy less, it will be a green building. Or else when we use the water, the natural resources, the air, and when we generate less wastage, and when we provide a healthier space, that will also make the structure a green one, right? And green building is designed to reduce the overall impact on human health and natural environment. So we know that what the building what we have here, the concrete buildings, right, without green, that will all emit the toxic gases, especially carbon dioxide, which will be responsible for the global warming, right? So these all have to be controlled, and when we have, or when we have the knowledge of green infrastructure, it is possible to reduce the toxic which is all emitted in the old buildings, is it? And reducing the pollutants, right? So it is not only our residential house which is creating a pollutant. We have to think about the industries and other buildings, infrastructures, which is all then and there polluting the land, air, and water, right? So this is green building, how it is giving an impact to the environment. So while constructing itself, we have to focus, is the building affecting the environment, right? So during construction, so we have to transport material from far place to the location. So or else we have to use the fuels, right? So during construction that will be certainly wastage of material, right? So how we can plan efficiently and conserve those useful materials efficiently, that we have to pre-plan. And while doing that occupation, right? Then renovation. So when we are retrofitting or renewing something, that have to be also a there have to be also a reduction in energy, is it? And at last, every building will have some lifetime, and after the lifetime, it is not possible to serve the function for what it is made, right? So there have to be a demolition. So while demolishing the structure, certainly there will be a waste, is it? So planning for that, how to recycle and how to make very efficiently. So those things will make the building green. And then, so why do we say that there is an impact in environment? Because during all these above activities, there will be a consumption of energy, water, the raw materials, and it generates the waste. Is it? So, like emitting harmful gases, right? The carbon dioxide is emitted throughout the life period. Then, so what is going to happen? There is full of concrete structures. We can say concrete forest, right? So then and there, here and everywhere, it is all emerging for every second. So what happened because of those concrete buildings, right? So there will be a toxic emission certainly, and which will lead to creating, and we all know the effect of those harmful gases and other pollutants, what is all coming out from the structure, so that we are going or we are thinking about the green building, evolving green building standards, and how to get or improve the standards, get satisfied, get rated for that, right? So when the rating is good, by increasing the amount of the harmness, or by reducing the amount of harmness, we can improve the quality of the building, right? So those things are discussed. So when I say about rating, it is LEED, so LEED certificate. So when we make a ranking for every building, so these LEED certificate are the famous one. It is leadership in energy and environmental design, or the green globes, model green home building guidelines. Okay, build green. These are all the standards. So when we focus on this and build our structure, we can obtain a green infrastructure, right? So next, the topic is not only sustainable green infrastructure, we have to learn what is resilience, resilient infrastructure. So according to me, the resilience is very important, because the structure, when it is met with an a disrupting event, it should not just fail suddenly, right? So we have spent more, or we have planned for its lifespan. So we cannot leave the structure to fail and get collapsed due to a event which is happening for a second, right? Like an earthquake. So if you plan for an efficient way of reusing, or efficient way of mitigating the effects, that will be very good, right? So the resilient infrastructure, we have to concentrate more in this current scenario. So what is resilience? The ability to bounce back faster after a stress. So is it possible? Yeah, it is possible for a high-storied building to get recovered from the effect of the stresses or loads, whatever is distracting it, right? So here they are saying resilience is the ability to bounce back faster after a stress or shock, and minimize the effect of stress. So there will not be 100% uh, bouncing back. There may be a effect due to a shock or stress. It have to be mitigated. It have to be absorbed, or the material have to adopt, and recover. Okay, making like that is a in resilient infrastructure. And resilience is about maintaining the continuity of service in the presence of the disruptions, right? So we are making the structure to continue continuing in its function. Okay, so making very safe from the disasters. I will list what are all the disasters which is all going to interrupt in our structure. So those things have to be just absorbed. It have to react to its uh, stresses, right? So that is the resilience. And this chart, you can see what the resilient infrastructure is doing before the disaster or before the disrupting event. So the material what we are focusing have to prevent. So first of all, the material have to be in a way to prevent the disaster, is it? So if it is preventing, it is well and good. There is no second thought of that material, is it? So we can first think about preventing the disaster. Later on, if it is somewhat high, the stress is more, we have to make way to protect, right? So it is not only preventing, we have to protect, then mitigate, right? So still, if it is not possible to protect and prevent, if that must be in a way to reduce. Is it? These are all the things we can do before the disrupting event. And during the event, it should not fail or collapse. It should not lose its own stability. It have to respond. So responding to the reacting with this stress and shock which is happening sudden is very important. So like respond. Okay. Then still more we have to think about after the shock or stress. So what is the much important thing we are focusing is recovery from the disruptive event is the vital role of a resilient material, right? So it is possible to recover from bending or flexure or buckling. Everything can be recovered. So that is what the resilient structure is. Okay, and mitigating, reducing. Okay, these are all the initial level. We can do it. And the next outcome, we can see some outcome effect of the resilient infrastructure, that is to resist. Okay, and during the event, it have to absorb. Okay, not only responding, it must be in a way to absorb. Then, after the event, it have to recover or adopt. Okay, so adopt is a smart word. We have to think lot. So adopting to the environmental condition. So if it is a very hot climate, or it is a cool climate, or a uh, hurricane or wind is affecting frequently, so it have to be in a way to adopt, is it? So that is also a resilient infrastructure. Then reduce failure probability. So risk reduction. So what is the risk? The building fail and collapse down to the floor. So that risk have to be reduced. Is it? So before the resilient infrastructure, we can think about reducing the failure probability, and after the thing, we can think about reducing time to recover, isn't it? So we have to, the material have to give time to recover the event, is it? Then reduce consequences from failure. So here we have to reduce the consequences from the failure. So see, if it is failed suddenly, So normally, how do we build a structure? We build the column, the vertical members, everything a stronger one, and we give uh, a liberty to the horizontal members, is it? So such things we have to plan and reduce the consequences of failure, right? So that will make a resilient infrastructure. Okay, now I can introduce some importance of sustainable construction, right? So we are talking about sustainability, we are talking about reliability. So why it is important? Why suddenly we have to change our traditional way of designing and traditional way of constructing? Everything is going as it is, right? So why it is the time to think about a change in the way we design and implement in constructing a new construction or infrastructure. Yes, it is certainly the time, a critical time to think about our traditional way of designing, um, the usual way of mixing the material consumption, everything have to be stopped, and it have to have some increased or a new thinking of giving an infrastructure development, right? So why it is important? So bringing a quality environment, right? So here we can have the air and water terms, the quality every time, or then and there we are seeing a polluted environment, and there is no possibility of rectifying it, and there is more human effect. It is giving an impact to our whole life, right? So what to do, or how as a civil engineer what we can do for improving that or reducing the effect, right? So something have to be done. We are all responsible for the effect. We cannot say it is not because of a single engineer, right? So we are there to build multiple infrastructures, and so that there must be a different way of thinking in order to have a change in the environmental impact what we are giving now. Then we have to plan for a healthy community, thriving and healthy community. So that we are in a stage of developing country. So soon we will obtain the grade of developed country. So in this aspect, when we plan for a sustainable construction, it is going to help our economic and the environmental conditions, right? So it is important to think about the sustainable construction. At last, we have to experience the clean air, natural resources, and a non-toxic environment, right? So this is very essential. Annex gives cleaner and greener spaces. So in order to obtain, we need this sustainability. At last, as the effect of climatic change increases, sustainability becomes even more important. So we are talking or we are hearing about climatic change, the impact of changing climates, right? So in our lifestyle, what is happening day to day, everything is because of this emitted toxic gases, right? So this is the right time. We are thinking about sustainable structures, we are thinking about green building. So everything has to be instantly implemented. It is not a costly process. It is a simple process, just linking with the nature. So nature will not what the nature is not going to cheat us. So when we have hands with the nature, certainly we can succeed. And one thing I have to share is the nature doesn't require a human support for its development, right? So without a human, the nature will be certainly happy, and without any barrier, it can extend its wings. But we humans need the support of the nature, right? Is it possible without trees or without the vegetable fruits and other sources we are getting from nature. So we have to give hands for the natural condition, and we have to work for enhancing the resources, right? Yes. So this commands will show you the need for sustainable and resilient infrastructure. The finances are seeking for a sustainable and resilient infrastructure. If you go for a financial help to the bank, they are very happy if the structure is a resilient and sustainable one. Is it? So that is a good one. We can go with the sustainable buildings. Next thing is the modern infrastructure plans can only succeed if they are sustainable and resilient, right? So when you want to succeed in our project, if you want to succeed in our infrastructure terms, then certainly it have to be a sustainable and resilient structure, right? Yes. So it is interesting to read this. See, either the country can risk further productivity decline, transportation congestion, and potential catastrophes for dilapidated the systems, or it can develop new networks. So we can wait until the systems are going to get worst, right? Or else we can think about a new network to accommodate the expected 100 millions of population growth over the next generation. So it is a quote by, it is a newspaper quote, right? So here what he have emphasized is it is, we know it is going worst and worst. We can leave it as it is, or else we can plan for the future population growth and making it a best one, right? So we are not going to leave it as it is. So all civil engineers, they all have the responsibility. It's our own duty to recover to its initial state. Is it? Initially, it is all pure and clean. So we will make the world pure and clean. By the same time, we are going to improve on. We are going to develop in all aspects. Right? Yes. So, what is the problems we are facing when we implement a sustainable development? Okay, or the thing is, why it is very important to think about the sustainable development. So here are some problems are discussed. The thing is, we are over exploiting the natural resources and the ecological carrying capacity faster than it can be replaced. So if you are extracting water from the bore well, it will get recharged so that we don't have any worries of thinking to the alternate ways. So if it get recharged automatically, we are using the water very easily without any worries. At one time, when it stops to replace, recharge, or replenish, okay, or restore its capacity, what will happen? There comes the problem, right? So we are going to experience those problems if we are not going to make any change in our daily routine activities. So that is the first thing we have to think about. Then mm, we are not replacing or fixing the infrastructure in a way that conserves or restores the natural resources. So that it is possible to make a structure without the usage of non-renewable resources, energies. Is it? So we can go with renewable energies like solar panels, and we can make use of the rainwater harvesting systems, so that there won't be any worries of expecting the vast system which is going to degrade. Is it? So the air conditions, the light, everything is available in nature. What we are doing, we are preventing the light, we are constructing a opaque structure, and then we are searching for light. The light is already available plenty. We can make use of a material which allows the light, right? Yes, and the wind, the breeze, the natural air, which is expecting to ventilate your structure. We are just holding them out, and then we are planning for a air conditioner, which is going to emit the toxic gases and exploiting the depletion, or it depleting the ozone layers and everything we know, right? So it is possible without usage of those evils, I can say that. We can have, or we can enjoy the natural resources when we plan according to it. It is possible. So those materials we will discuss in the further slide, and we are talking about the problems, right? So the old designs, the old mixture of concrete, right? So how do we make the concrete material, the cement, lime, those sand, river sand, then the water we use, the aggregates we use. So those things, in that we have to think for a change in the material. So we know this material is not that much worthy of promoting, is it? So we can plan for a material which has a less impact on the environment. So that is all today's problems what we are facing. It is listed there. And next we will think about the replacing activity in order to reduce such problems. So next is a question asked, repairing our infrastructure the same old way, or building a sustainable infrastructure for the future. So repairing, retrofitting, renewing the building, it is not needed. When it is a sustainable one, the building is going to be there without any damage, without fading, without reducing its efficiency. Then we don't want to think about repairing it, right? So certainly we go with the second, it is building a sustainable infrastructure for the future. Is it correct? Yes. So how to go with this sustainable infrastructures? By knowing about the material, right, and how it is consumed. If we are encouraging the production of sustainable material, and as a civil engineer, certainly we alone can promote this, is it? So that we have to know how it is made and where it is made, what are all the ill effects and how costly it is. We can compare and we can implement those things in our real projects, right? So that the people will come to know about the benefits, and they will certainly support this sustainable materials. Is Albert Einstein's quote, you cannot solve a problem with the same sort of thinking that created the problem. Is it correct? So the problem is us. We are thinking in the same way. We are we don't think in the other way, which have created the problem. Is it correct? So what is the other way? That is the green infrastructure, that is the sustainable one. If we think differently, it's hard to think. There will be limitations like learning new skills, and the laborers, the workers, we have to make them support. So there will be some constraints. So, but it is time to think in a different way to solve the problems what we are seeing now. Is it? The next is what is sustainable construction? So I told about the problems we are experiencing, and I told we have to think in a different way in order to mitigate the environmental, economical, and social impacts. So what is that? That is the sustainable construction. So this practice of creating a healthy environment, right? So how we can say or when we can say the environment is healthy? When it is in a way of balancing the um, living things and non-living things, the plants and humans, everything has their own duty or their own rights to live in this world. Is it correct? They have a part to take in this world. It is all created. We cannot reduce or we cannot deplete anything. They also have to be taken part. As we are all dominating, those minor organisms get depleted. They are all vulnerable. So we have to think in a way giving opportunity for every living organism, even if it is not visible to our eyes, it is helping us in some other way, is it? So directly or indirectly, they are all having the rights to take part and they are not going to harm us. Even something is looking like harming us, we can make them useful, is it? Yes. Here, to make a sustainable structure, six principles can be followed, right? So that is conserve. We are using the resources efficiently. That is conserve. So the fuel, is it? The fossil fuel, if we use efficiently, that can last for a longer time. So that is also make the sustainability, right? And the next thing is reuse. So recover is different and reuse is different, is it? So recovery. So when an item is used and without any change in the process, if it is possible to use for the next time, it is called recover. And reuse, is it recover or reuse? So such materials are most welcome, but the other everything cannot be reused like that, right? So plastics, those things cannot be reused. That can be used only after going through a process of recycling, is it? So when we plan for a recycled and renew, then that will also make the sustainable material, is it? And protect nature. So if you are planning for a sustainable infrastructure, certainly we have to think about protecting the nature, right? And create non-toxic. So if you suggest a material for your infrastructure, then we have to know top to bottom of that material, what it will do after construction or during construction, how the material is going to be demolished or reused. Everything have to be known, right? So without knowing its effects in every phase, it is not possible to have a sustainable construction. And the last thing is high quality, right? So quality is important. It is not only going with the nature. We have to think about the quality of the material, how it is performing in high compression or tension, flexural loads, how it is behaving. That is also a prime factor when we suggest a sustainable material. Yes. Now the methods. So how we can make a sustainable construction? It is by following those like recycling and constructing a green building, right? And renovating a building rather than building a new one, right? As I said, it is possible to make it again for the function what it is serving without demolishing it. So in that way we can use or make it a sustainable one. Then managing the carbon dioxide transmissions created by construction sites. So just we have must have a plan to manage the effects of toxic gases, right? Conserving energy. So those things are the repeated one. And here it is given an example like recycling food packaging or using reusable containers, not smoking, minimizing paper usage. So these everything, if it is followed in your institution, if it is followed in the infrastructural plan, then it can be a method of constructing a structure sustainable. Okay, so it has discussed about the benefits of sustainable construction. So five benefits we can quote. One is reduce waste, right? So if structure construction is reducing the waste, we can say that it is a sustainable one. So waste reduction and recycle, even if it is producing a waste, that must be in a way to recycle. Is it? Then conserve the energy using less power, using less water, using less material, raw material. That is all a sustainable construction. When we follow this, we can enjoy all these five: building green buildings and use sustainable resources like a renewable energy. If we use, we are then get benefited. Is it? So here further it is all made elaborately. The cognitive courses, scores, is it? When we rate the impact of the infrastructure which is giving to the environment, the rating will get increased. If it is a green building, 61%, is it? So that is a good score. So that can be achieved when it is a sustainable infrastructure, and we don't want to worry about the uh, disorders or the environmental, external environment. So those will be the benefits. Then reducing waste. So the chemicals and toxic gases that will be get reduced. Certainly the economy we can improve, improvement of the economy. So how we are going to improve? Demand for labor is increased. Is it? If an engineer is skilled in constructing a green building, a sustainable building, a resilient material, certainly the offer for the labor will increase and the economy we can increase by implementing those projects. Is it? Then promote sustainability. People can see how efficient everything is. Is it using the renewable energy? It is promoted. Then we are going in this stream. Okay. So as I mentioned previously, there will be a challenge when we change from the conventional method to a new construction method. So what is the challenge here? They focuses takes time and preparation to utilize the best practice. Is it? It is not easy to learn the methods or learn how it is designed, how it can be used as a building material. It takes time. So that is the new trends. Everything has to be taught by us as teacher. As a teacher, we can introduce those things to our students so that they will be benefited. They can know about these sustainable material. Is it? So that we can do. And here training need to be implemented, right? So the employers, they need training. They will be trained in the traditional methods. So these things can be focused. Then the higher principal cost of sustainable construction than demand. So now the demand for a resilient or sustainable material is very less since it is not known by others. So when we are giving them the benefits of the sustainable materials, so certainly they are going to choose this material as their building unit, right? So that the cost is high. Then the demand is more, we can produce the material for a cheaper cost, and we can make this issue less. Is it? Yeah. So now it is the time to know about the sustainable building materials. So natural building materials. So when we think about the green buildings, so these materials are very playing a vital role. Here, first thing is about bamboo, right? Recycled plastic or recycled glass, recycled tire, recycled steel. Those things will also be in this sustainable material list because we are not producing a new one, we are making it reused, is it? Next is the laminated timber. So we don't want to cut down the trees for the need of wood, right? So we can make it into slices and then it can be made as a block for our own requirement so that the wastage will be less. So why do we prefer timber in our building? It is a good insulator, right? So that can be done when it is a laminated timber, right? So then stone. So stone, it is not artificially produced, so it is a long-lasting, sustainable material that can be used, right? A cob is a mixture of sand, lime, and straw, so that it can make a natural material. There is no need of preparing. A technical process is not there, or it is not undergoing any fuel burning. So those things will be reduced, and it is a natural one, a good insulator, right? And cork. So cork is a natural material which is obtained from the bark of the cork tree. So it is not needed to cut down the tree, just the waste bark can be removed from the surface, and then we can make use of this carved material into the required size. Adobe brick. So adobe brick is what the brick, it is not the normal brick which is burned in the kiln. We don't want to burn, it is just dried in the sun in order to get a shape, and the dried blocks can be used for building. Is it? So when it is demolished, it can be again reused. So that is the best idea of having a adobe brick. Then here there is a precast concrete. So concrete again, yes, a precast concrete will be in this list because the precast concrete is made for the required dimension, and the term or the lifetime of this unit is very large. Okay, it has a long life, so that it can be added in this sustainable building material. And next, a pollution absorbing brick. So how do the brick absorb pollution? It is having layers. It is not a single layer unit. We have two and more layers, which is all having some perforations. So through those perforations, there will be an intake of air which is polluted. Those particles will be restricted from the first layer, and it will allow the pure air to come in. Right? Okay. The next one is 3D printed concrete. So an emerging technology, 3D printing, right? So this 3D printing, we can design the length and thickness with everything previously, and we are using a building material, and those printing will be done for the required designed dimension. Okay, so it is very uh, essential for this sustainable material. So I'll show you the diagram for the 3D printing. So it can also be in this list. So as I said, recycled tire, glass, steel, aluminum, those things will also be added next. So this is the detailed benefit of bamboo. So why do we go for a bamboo? Because easily grown or fast growing tree. It is having a good tensile strength. The fibers is good in absorbing the tension, right? So it can be compared to the steel what we are using, so that we can encourage the growing, harvesting of bamboo. So while harvesting bamboo, what happens? The gas which is absorbed as carbon dioxide is more than the tree is absorbing. Is it correct? So that this can be suggested as a building material. Then recycle the plastic. So here also we can end up with filling the lands. We can end up with polluting water with the plastic. It can be recycled, right? So it doesn't require a toxic preservative or sealant to connect. So it is easy to connect and make a sustainable material. So this is the laminated timber. So we call that as a cross laminated. So the strength of this timber blocks will be very high, right? So that we don't want to cut down the trees. Stone. So stone, what is the main benefit we can point out? It is it won't need replacing. So if it is a brick or if it is a concrete, somewhere after years it is going to lose its shining or it's going to lose its surface particle. But stone is a sustainable unit. It will not need any replacing, okay, is recyclable for the use of other projects. So once the compound wall it is made of stone is demolished, the same unit can be used as a foundation blocks, is it? So that it can be recycled very easily. I told about cork. It is a mixture of lime, sand, straw, and soil. Right? It is inexpensive. It produces less carbon dioxide, and you can see the units like a fresh mixture. Right? So that will help you in insulation also. It is a eco-friendly material. The core block bricks, right? So it is the benefits we can say smaller carbon footprints. So the emission of the carbon to the environment is very less when it is a core, right? While production. So when you want to produce a brick, the carbon footprint, everything is high, right? It have to be burned in flame, it have to be treated, there is a usage of water, everything is made. So, but this cork is a weightless, so it can be used for a less weight building material. Then adobe brick. So adobe brick is also the same. The mixture is dried in the sun and those blocks don't need any heating. Okay. The benefits we can say that natural insulation property and keep the indoor temperature consistent, right? So when we enter into the hut or the olden clay walled house, we experience a good condition. Is it the indoor temperature will be very less, but we couldn't sit inside the concrete high-story buildings. It is all because of the natural insulation property of this concrete is less, but it can be achieved by the adobe bricks. Precast concrete. So we have to cast the elements somewhere in a factory or laboratory. Then at once we can build it to the required shape. Is it? It can be transported and then uh, uniting it into a block is possible. Then pollution absorbing brick. So this bricks will absorb the pollutants, what the small particles, what is all mixed with the air. So that will give a good space for the inhabitants, right? Then this is the 3D printed concrete. So you don't have any wastage of material. It is all done uh, in a less time, right? And saving money, the energy, everything is less. Then ability to print on demand leaves, no waste, save energy. Okay, it saves transporting material. We don't want to walk here and there to transport, purchase, nothing. We can just design and then give time for it to build. That is it. Okay. So this resilient material, or it can be added in a smart material also. So it is some of the new materials I have listed here, which works very smart, which works very resilient for the stresses, right? So one by one we can make it. Regenerative bioconcretes, or a living concrete, we can say, right? So how to make the concrete live? By mixing a bacteria called bacilli. Is it? So what is the need of a bacteria there in concrete? So we know the concrete is a brittle material. It is induced to cracking and shrinking. Is it? So there will be cracks. So crack is the main ill effect it is giving. So how automatically the major and minor cracks can be filled. So is it possible to fill the cracks? So which is not at all visible to us, a micro crack, what is the crack going to do? If it is cracked, it allows, it permits moisture content, right? The water, everything into its medium. So what it will cause? It will cause corrosion to the reinforcement embedded in its matrix. Is it? So how to automatically, there is a one who is going to help us by creating line, which is going to fill the micro cracks what is created then and there by stresses inside the concrete. Okay, so that is a good one we can use as a sustainable material. So it will survive for 5 decades without food and oxygen. That one we can think about this. So implement those things in our future project. Next is a carbon concrete. So carbon concrete, we are using some strands, fibers, which is all made of carbon. The meshes we can use instead of iron elements. So what is the main benefit of ignoring iron elements? The reinforcement is giving high dead weight for the structure, is it? So the self weight of the structure itself is a big task to manage. So when the self weight of the structure is brought less, what happens? The strength of the structure is going to be compromised, is it? So what to do in order to have a strong building element, and it have to serve for the function also. It have to hold the heavy live load and dead loads, wind loads, earthquake loads. So there is a material, it is made of carbon. So those carbon fibers are made with the concrete. Okay. So this mesh, as a mesh, we have to spread it while handling, so that this material will help us to make a sustainable concrete, right? So the carrying capacity is also good. The thickness of the elements can be brought lesser. A big dam you are going to construct, a bridge you are going to construct, there is no need of fear of high thickness or and diameter. It is possible with a fine elements. Then hydroceramic. So there are more trends which is implemented hydro, water, is it? So water particles can be absorbed by this concrete. So it is mentioned 100 times more than its volume, the water can be absorbed by this concrete. So what is the use of absorbing the water or wetness? It can be served as a thermal insulator. Is it? So when the surface is very cool, the structure is going to be a one which does not require any comforting energy which is used for depending on the power, right? So air conditioning or a fan. So those things will be less when it is made of a hydroceramic material. So here certainly we have to talk about this self-cleaning materials. So is it possible for the concrete material to clean itself? Yes. So it can be done when we add titanium dioxide. Is it? So titanium dioxide ions, when it is react with the particle, it is going to emit with the presence of sunlight. It is going to emit the nitrates, right? So these nitrates that can kill the um, what the dirt, or it can absorb the dirt and make the surface, it improves the process, is it? So that it is implemented, and they have proved 51 percentage of reduction in the polluting gases, is it? So as a paint also, it is possible to apply on the surface of the concrete material, so that the structure is going to be a dirt free, is it? Right. The next, thermal bridging. So what it is thermal bridging? So this sun and the radiation of the sun is troubling us a lot. We are getting the heat inside immediately when the radiation is get contacted with the surface. Is it? So is there any possibility of limiting or limiting as an insulating material? Yes, that is thermal bridging. So what do this thermal bridging does is, it is a layered element. So there will be two or three layers. Okay, one layer is made with the insulating material, and within that second and the first layer we will have some free space. So what do this free space do? It will not allow the radiation to pass to the inter indoor space. So that is a benefit, and here the R value, so that is the thermal resistant value is more than 40 percentage we can achieve. So this is thermal bridging element. Yes, photovoltaic glass. So this material, why do we adopt glass? So in order to allow light to pass, and we don't want the hot radiation to pass, is it? So it is possible the heat will be absorbed by those panels, solar panels. Um, it will be transparent also. We can make this photovoltaic glass very transparent, and it will not allow any heat to transmit, but those heat will be used as a efficient energy for producing electricity. So this is all practiced in many projects, many useful structures. It is all done then and there, and here it can be used efficiently in windows, the facades and roofs, is it? So it is possible to make a sustainable making use of this glass. Next is kinetic footwall or kinetic roads. So what this is doing, the load which is being given to this material will be converted to energy, the electric energy, right? So it generates the electricity when we are passing by. So the vehicle which is all passing by this road, which is made by this material, it will automatically generate electricity, which can be used as a street light source, or it can be used for recharging the electric vehicles. So it is all possible. And the roads, is it? So here, when it is made as a material for the road, it can be certainly used as a energy producing unit. Next is the smart concrete. We call concrete smart when it has a property to change its shape, right? So shape is made shifted. It is not made frequently. It is made when it is meeting a heavy force or when it is meeting a heavy wind. So such things can make the structure shifted, right? So the structure can efficiently handle the wind pressure, the wind load when the shape is changed with cylindrical form. Is it correct? So automatically it can sense the forces or loads, and automatically it is being molded or changed to a shape which can deal with the adverse environmental disasters. Okay, it is implemented in earthquake resisting areas or hurricanes. Those areas it is effectively implemented. So as I said about the concrete which is producing electricity, right? So that can be used effectively. It can also be a smart concrete when the original raw materials are added with potassium ion. It will have a capacity to store electricity for a long time. And what they are giving is one day the engineer can build a wall which can store a lot of energy which can be used as a battery for serving the power need. Okay, it is all possible. So that is a smart contract. Then shape memory alloys, a resilient material. So shape memory alloys. These alloy is a mixture of metals, is it? So here we are using nickelon, nickel, titanium, copper, aluminum. So these material can be used as a one which can regain to its original shape after experiencing the uh, disrupting event. Okay, so when it is infused to high temperature or when it is infused to high vibration like a earthquake, it can be reformed to a rollers. Right? We have heard about the base rollers, so base isolation materials. So when these materials are adopted at the foundation, so it will change the shape to the need and it regains to the original when it is sensing normal temperature. Correct? So the material which can sense temperature, humidity, pH level, the light, wind, stress. So all this can be a effect, and with this effect they are having a capacity to change itself, and which will be a useful material for us, right? So here we have some types of shape memory alloy. It can be a one-way shape memory alloy. That means it will respond only for heat or it will respond only for cool. And the other one is two-way shape memory alloy. It will respond for both heat and cool, right? Okay. So even after having this benefits, we are not known or we are not much using. So there must be some limitations, is it? So the limitation they are pointing out is the magnitude of deformation. Okay. So when it is deformed, the performance is degraded. The lower performance in magnitude of deformation. Okay, their durability is becoming less. So that is not needed for us. This has to be reduced. Next is the reaction to temperature can be modified quite easily. So it is much difficult to control the response for the temperature. So that can be added as a limitation. So this is all about shape memory alloy. I can show you how does it work, right? So when the temperature is normal, it is looking like a a small a horizontal rod, right? So, but when we are increasing the temperature, what happens? It becomes a curved bar, is it? And when the temperature is get normal, what happens? It will memorize its previous shape. So, what is the previous shape? A horizontal one, is it? So that it automatically goes to the original shape. So that is going to be implemented as a sustainable material. So how it is effectively used for our field. So what is the uh, effect we are experiencing in concrete? It goes cracked, is it? So those cracks in the concrete can be restored when we paint or when we coat this shape memory material over the surface of the ordinary building unit, right? So this is much helpful when it is added with elastic polymer network. It is possible for the structure to reform and then come back to its original natural state without any cracks. It is possible by the self-healing material. So here they are giving an example of self what automatic material, that is shape memory alloy material. It is used as a shoe, is it? So when we want to wear the shoe, the temperature have to be increased. So what will happen when the temperature is increased? The element get loose and it can be worn as a socks. A flexible one it will be. Okay, when it is heated. And later on, when it get continues with our own climate and our own body temperature, it becomes rigid. So when a flexible material becomes rigid, it acts as a rigid shoe, is it? So later on, by the increased temperature, it will be flexible only. So later on, by its temperature, what will happen? It will again have the capacity to be flexible, right? So such kind of innovations they are making with this smart materials. We can also implement this in our civil engineering projects. Yes, so it is time to have to discuss about life cycle assessment. So what is a life cycle assessment? That is, it is analyzing a material. So if I am suggesting uh, some green material like a adobe brick, we have to analyze what are all the raw materials here, how it is extracted, and how we have to transport to the site, and how we have to build it, how we have to produce, and then what is the lifetime, and after its lifetime, how it is going to be demolished. Why demolishing? Is there any impact to the environment? And is it possible to recycle the material? So if you are fully analyzing the material starting from its origin to its demolition stage, then it can be rated. Okay, so based on the impact the material gives in each and every phase, it can be rated. So the material which is giving less impact, that scores the more, right? So here a flow chart I can show you. So this is a cycle of a material repeatedly happens. The first thing is raw material is extracted. Then the material is produced. Okay, so it can be produced by like an I section or element. Then it have to be manufactured. Then it have to be utilized. After the period of its service, it have to end its life. Is it? Then afterwards, it have to be recycled. So analyzing all these terms, then we are grading a material, that will be called as a life cycle assessment. Okay, see, I can compare brick and a uh, adobe concrete, adobe blocks. So while comparing the LCA of brick, what happens? We have to collect the clay material and we have to use water, a lot of water. Is it? And then it have to be burned. So the carbon footprint or the usage of fuels, everything is more. Is it? And then after the service, it cannot be reused, right? So, but when we compare with adobe brick, what happens? It is a natural mixture of clay and straw and water, so that after its demolishing, after its life cycle, it can be again reused, right? Yes. So here also they are explaining, I have explained with a flow chart, that is the input. So what are all the sources we are using? We are using fuel, we are using electricity, we are using water for producing a building material. Excuse me. So what is the output? The output is the emission of air, the emission of water, the emission of the pollutant to the water, emission of pollutant to the land. So these are all the input and output. So the input have to be also be used less, and the output have to be also be released less. Is it during the cycle? What is that extraction of raw material? That itself. If it is a iron usage is more, the mining is needed, is it? In order to get the ore, metal iron ore, we need extraction. The energy used is much. Next, processing. While purifying the iron, the processing is more. And then it is not available everywhere. It has to be transported lot using diesel fuel for transportation vehicle. Next is construction and retrofitting. So when we cut the material, there is a wastage. It is not available in the required size, right? So there is a construction and retrofitting wastage is there. Then the maintenance. So it is not easy to maintain the iron element, is it? So we need much more cost and time for maintaining, and at last demolition. So if it is easy to recycle, it is well and good, right? So this shows the life cycle assessment cycle. Yeah. Here we can discuss about some principles, outcome principle and the process principle. The outcome principle, we have to think about social, economic and environmental effect, right? And process principle, we have to think about the ethical, stakeholders and governance. So all this have to be kept in mind, and at last the performance have to be harmless, preventing harm, preserving correct values, creation of positive and restorative values, right? So all these principles are going to give us a material which is effective in its performance. So here the triple bottom line based on the outcome based principle. We are focusing on social, economic and environmental elements, right? So how to prevent, how to sustain and enhance, it is all done. Then the next will be based on the input basis, right? So here it is ethically we have to think while preparing a material whether we are ethical to the um, ecological elements, right? And governance. So, is there any risk in managing or risk in promoting? Those things we have to check. And stakeholders, it is also important, right? So it is sustainable matrices. So when we think about the economic, So funding, land value. So do we need need of encroaching the land, the cost, everything we have to suggest, and certainly the environmental terms like quality or compromising with the pollutants we are producing. Then the policies we are following while producing a material, that is also important. Then the customers perception, okay, how they are encouraging the elements which is produced in a sustainable way. So as we discussed previously about the lead rating, so when the material is performing good, the rating for our infrastructure is good, and we are going to get reputed by the government and other organizations. So here, the green building or the sustainable building, how it is rated. So when we give importance for the pathway, so what percentage of weightage we get, okay? So when it is for the water resources and environmental concern, how it is made, those things will also give some wastage for, sorry, it is giving some weightage for our performance, right? So if the building is getting 100 percentage of weightage, it is perfectly good, and we can try to score weightage for our building which is produced based on this sustainable and resilient materials. Okay, so I can say that the government, which is also helping us to promote the sustainable structures, resilient structures. They are planning for building which is sustaining and which is responding to the events, right? So what is the thing I can share is in the recent summit on 23rd September 2019, we are having a plan. The government have planned to invest a lot to make infrastructure resilient, and it is going to contribute to the economical growth. Okay, so see here, they have a plan to invest 80 trillions dollars for building such sustaining structures for in the next 15 years. So it is a good news for all our civil engineers who are all thinking of making a project with the sustainable designs. Is it? So it is good for us to here the government is also in a same way which is making the environment beauty. And here the resilience of a structure. So what are all the risks the structure is going to face, right? So it is not only the natural disaster which is disrupting us. We don't want to just focus only on earthquake or hurricanes or cyclones, the tsunami, like this. Okay? So it is not only that the artificially made things, okay, that can also trouble us. We have to frame for being resilient for these issues also. So what are all the issues? So for this uh, instantaneous situation, it is not possible to live without power, is it? So power is needed for illuminating the indoor, or else it is needed for making comfort. Right, right. So for operating every machine, it is all reliable with the power. So when there is a power cut or there is a loss of power, how we have to behave, right? So that is also a structural event what is going to affect the infrastructure. So the next is that communication. So we need internet communication, we need a telephone communication. So, is it possible without the um, conventional power or conventional fuels? Okay, so everything have to be done naturally. So when it is a green building, when it is a sustainable building, without any extra power which is supplied, we ourselves can produce. Is it so? So that is a sustainable building which have to be appreciated. Okay, and transportation, health infra, urban infra. So these all will be a disaster they are listing. And here also you can have natural disasters like earthquake, volcano, and mass movement like a rockfill landslides. So the structure have to be in a position to respond, in a position to react for this disruptions. Okay, so not only geophysical disruptions, hydrological disruptions like a flood, okay, then meteorological disruptions like a storm, cyclones, climatical disruptions like a drought, wildfire, and extreme temperature. Okay, here some key components of outputs we can rate, right, at last. So it's time. The sustainability is happening. We can lead or we will be led, right? So we human beings or we civil engineers have to realize that this is the fine time to lead towards the sustainable materials, right? So, or else naturally it is happening. If you are not cooperating or if you are not doing it that way, somehow it will make us to go in its own way, is it? So before that we can have ideas about the sustainable materials, sustainable benefits, and then we can go in hands of this natural elements. Yes. So I hope this presentation was much helpful for you all, and I have shared my views on the modern, sustainable, and the resilient materials. Thank you. Is there any queries?
If you have any queries, can you please ask?
Yeah. Any projects you have suggested for your students using these sustainable material you can discuss? What feedback you got? What difficulties you faced?
Madam, can I speak, ma'am?
Yes, sir.
Yeah, actually, you said about the resilience and you spoke about the structural health monitoring along with it, right?
Yes.
Yeah. So when you speak about the structural health monitoring and when you relate it
Yeah.
with there is your resilience, so how far these two are connected in the real structures? Like you can monitor the structures and whether there is any feedback system like this has to be done for the structure to sustain for another say period of time. So those type of feedback mechanism, is there anything devised yet?
Yeah, sensors we can implement within its constructing units. So it will be there for monitoring its health. And whenever there is a effect, ill effect task, it will be directly sensed and it automatically can repair by its own. So there are elements or there are practically done bridges are made with those sensors and what the resilient materials. So we just want to monitor its functions. So it is enough for implementing those materials during the construction stages. Right?
Actually, when you keep it now, whether that gives a feedback of the system, right? We have to just do it
Yes.
like we have to
Repair
rectify
it.
the structure. Am I correct? Or repair it,
Yeah.
or you
Yes,
told
yes.
for a repair
Yeah.
or rehabilitation or whatever it may be. Other than that, can you just integrate it with something like self healing, like that
Yeah.
actuations? Is it possible?
I hope this shape memory alloy material, if a bridge is fractured, deformed by a heavy load, so certainly when we have give time for it to restore, it can automatically done without any external help.
Yeah, why I asked this question is you in your
Yeah.
initial part of the presentation, you said about it will be regaining its in the resilience when you explained, you said like you are going to get it
Yeah.
regained. So that
Yes.
scenario is bit lesser because unless you do a repair or rehabilitation, the regaining of a structural phenomenon is presently it is not available. So is there any research going on that regard? That's what my question was.
Yeah, I have read about the modern construction materials.
Yeah.
So,
So let
yeah, there is sensors and there is self uh, repairing or retrofitting systems can also be adopted. I hope, but I don't
maybe in a due
think
course
it.
it may come, like
Yeah, yeah,
integrating
yes,
with AI or something in the civil engineering
yeah, yes,
perspective. Probably that may also come up. Self healing,
yes, yes.
or it will regain its lost things.
Mm,
That's what
yes,
I we can expect for. See,
yes, yes.
all of you, please ask some questions because this is a discussion forum. It's nothing like we will get more ideas on either direction. So please discuss. I think many of us are faculty members and there are students too. Please open up.
I can just hear someone say how the opinion or feedback about the presentation. That is also good. I can hear, I can feel that you are listening.
I think it's a since it is a new topic, probably
Thank
many
you.
are thinking about it. Probably,
Yes, sir.
yeah. You can, if nothing is there, we can proceed because
No, I came to my end. Yes, that's all.
Thank you, ma'am, for your innovative talk.
Yes,
Thank you
yes,
all
ma'am.
once
Thank you.
again. Have a
Thank you
nice
for
day.
giving this opportunity. Thank you, ma'am.
yeah. We are also very grateful to you, ma'am, because within this 1.5 hours, you have come across many, many details. So, if possible, you may
Thank you.
please share, if at all there is nothing, private documents or private research is involved, we can share the PPTs with us so that it will be shared among all the participants and it will be eye opener to them, ma'am. It's our request.
Okay. Certainly,
So,
sir.
yeah.
Yes.
I think thank you once again
Yeah,
from
I
this
will
family.
share.
So tomorrow we will be having sessions starting at 9:30, probably by offline session and then two online sessions. Over to you. Thank you. Shreya, you can conclude. Thank you.
Thank you all for attending the session. It was very innovative talk. Thank you and have a nice day.
Please do take time for completing the feedback form.